Assalamualaikum warahmatullahi wabarakatuh. My name is Saiful Haris bin Ghazali. So today we will be presenting the Arduino mini project which we choose to develop a smart door access control system with password, RFID and push button. So let's start with the problem statement. So our first problem statement is, can the product fulfill its function properly? And our next problem statement is, will it provide more convenient and quicker access compared to the traditional keys method? Our next problem statement is, does it have safety features to ensure the product's reliability? And then our last problem statement is, will there be no potential electrical hazards can occur? So let us move to the objectives. So our first objective is to ensure the door access control system is working properly. The second objective is to make sure the process of the opening and closing the door to be quick, simple and convenient. The next objective is to remain the security features of the door access control system steady, so that the system is private and secure. And then our last objective is to avoid any electrical hazard from happening within the control system. So we move on to, so this is the list of components that we use for this project. So we use Arduino Uno, RC522 RFID kit, the matrix membrane keypad, LCD display, solenoid, the relay, the push button, the piezo buzzer, and the solderless breadboard, jumper wire and the resistor. So this is our schematic diagram for the circuit we made using the freezing software. So we use keypad, RFID sensor and the push button as the input to open the lock. The keypad and RFID is at the the exterior side of the door, while the push button is for the interior side of the door. For the output, we use the I2C LCD display, the solenoid lock and the buzzer. So here for the keypad, we connect the keypad to digital pin 2 to digital pin 9. For the RFID sensor, the SDA is connected to digital pin 10. SCK is connected to digital pin 13. MOSI to digital pin 11. MISO to digital pin 12. Ground to ground. 3.3 volt to 3.3 volt, and the reset is to the analog pin A0. For the push button, we will need a resistor. So this is where the resistor is used. We will need a resistor of 10 kilo ohm that is connected to the ground. One leg is connected to the 5 volt and one to analog pin 12. For the circuit, we use the I2C LCD display, which only has 4 pins, unlike the standard LCD display. It is connected to power. Its connection is power, ground and SDA pins, which is connected to analog pin A4, and SCL to the analog pin A5. For the lock, we use solenoid lock, which goes to 5 volt relay module that is connected to ground, power and the signal to analog pin A3. For the last one, the piezo buzzer is connected to analog pin A1. Next, we will show the simulation of our circuit. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abqari bin Abdul Razak. Next, I will continue with our simulation and coding for our circuit. So this here is the code that we made action. Here we made the circuit using the Arduino Uno. Here is the keypad, the I2C LCD, the Rfid sensor, solenoid lock connected to 5-volt relay module, and batteries, the push button, and buzzer. Let's see how it works. Pressing the password that's set to be 2401, then pressing the hash button will open the lock. It will be unlocked for about 5 seconds before being locked again. Pressing the wrong password, it won't be unlocked. So this is the code. Pressing the numbers will print out the stars on the LCD. The sound made by pressing the button when the password has become 4 numbers long and the same as the password set before. Then pressing the hash button, it will call and trigger the set lock function. Then after a few seconds, all values will be cleared. When pressing the wrong password, it will show the wrong password here, and after a few seconds, all values will be cleared. This is the set lock function. When the function trigger is true, it will be locked and playing the tone. When it is false, the lock will change to high. It will be unlocked for about 5 seconds. And usually after false function is called, true function will be called right after to lock it back again. Pressing the ABCD button, it will just set to be invalid key. So this is the code here for the ABCD buttons. When pressing the start button, it will clear anything that already been pressed. Here is the code. When pressing the start button, everything will be clear. Next for the input is the RFID sensor. When we scan the card or the key tag, when it is the right code set, it will unlock the door. And when scanning the wrong card, it won't trigger the lock. It needs to first define the code for the card or key tag that need to be used here. When the card is detected and with the right code, the good tag here change to true, which then trigger the lock function, the set lock function that unlock the door. Next for the input is the push button. Push button is used from the inside the interior of the door. With only by pressing the push button, the door will be unlocked. When the button is pushed, the button state change to high, which then trigger the set lock function. Then open for 5 seconds, then it will be locked again. Additional sensor that can be put is the infrared sensor. For the circuit, as there is no other pin left, we replace the buzzer so there will be no sound. Using remote, being far away from the lock, the door will be able to be unlocked. Here I set it to be button number 1. Pressing it will unlock the door. As we can see, there is no sound. As we replace the buzzer with the infrared sensor. It needs to first define the code from the button of the remote here. Replace the buzzer pin and remove any buzzer from the code. When it receives signal from the remote, the same with that defined before, it will trigger the set lock function, thus unlocking the solenoid lock. So the three main input that we use for our circuit is the keypad, the Rfid sensor and the push button. We can use any input, whichever the turn. That's all from me. Thank you.